Hello, everyone. Welcome to this bit of our podcast, episode number 4 for IEEE ComSoc Technology News. Today, I have with me Professor Davide Dardari from University of Bologna. He's a full professor in the Department of Electrical and Information Engineering, University Marconi, if I said it right. And he has received a number of awards, including IEEE Communication Society Fred W. Ellerstick Prize and several other Best Paper Awards. And he has been a distinguished lecturer as well for IEEE ComSoc from 2018 to 19. So with this, I welcome Professor Dardari with us today. Thanks for joining us. So today we are here to talk about the topic reconfigurable to non-reconfigurable wireless connectivity. So we'll discuss about several aspects of this. So I would like to start by saying Davide is, so we hear this term quite a lot recently, especially with our colleagues who are working on it, called reconfigurable intelligent surfaces, or RIS, or RIS as they call it. So what do you think about this technology, and are there any limitations associated with the technology that you can talk with your audience, with our audience about?
So this technology obviously is an appealing technology today. He received a lot of attention in the research community, I would say, the last 3-4 years, we say. And it is very promising technology because it allows you to, for instance, reconfigure the wireless propagation environment in order to optimize the communication in principle at a low cost and with low energy consumption. So for several applications, it could be an interesting technology, especially to realize the concept of smart radio environments, okay, in which you can configure the environments using this technology. So that RIS is considered as one of the key potential technology for 6G. Obviously, RIS have some competitors.
Yes.
They have some advantages but disadvantages. One disadvantage of RIS is also one of its advantages. I mean, the reconfigurability. Because in order to make the RIS reconfigurable, you need to design a control channels. You need the control channel, you need a dedicated protocol, you need some stuff to put behind the RIS in order to not configure it, and so on and so forth. So that requires a little amount of energy, so it's not, let's say, energy free. So that in some applications, this kind of, let's say, limitations could be important and could prevent the adoption of RIS in favor of other solutions. For instance, one competitor of RIS is given by the smart repeaters.
Right.
They are active, so they can boost the signal power, and they have similar performance of RIS. So this is could be some limitation. In addition, today, for what I know, there is not a clear business model for RIS. For some specific application, yes, but I would say not in general, especially for what regard the cellular system. So it's not clear today what is the real business model.
Right.
Yeah. So this is the, in my opinion, are some applications. In addition, we need standards, because as long as service provider to, let's say, reconfigure the RIS, so we need a standard. And also there is the question, who is going to reconfigure the RIS in case you have multiple service providers?
Yes,
so
yes.
all these stuffs can, let's say, put some limits to the limitation of the adoption of RIS. This is my opinion, obviously.
Yeah. Right. And following up on that, so what do you think about the alternatives to RIS technology? Is there any other sort of technology that you can think of? So you mentioned about repeaters, or some other, sort of active RIS and some other sort of counterparts of RIS technology itself. So can you think of any other alternatives on RIS?
Yes, obviously, if you increase the complexity, you have, as you mentioned, the repeaters, active RIS, and so on. But if you want to lower, for instance, the complexity, the energy consumption, and also avoid some of the limitations of RIS, we can consider, for instance, the smart skin, so basically completely passive RIS, or say static metasurfaces, so that they are not reconfigurable. Okay, so these are often called smart skin because they are supposed to be, deployed like a sort of poster or paper on walls and so on at very, very low cost. They are completely passive, so that you don't need any energy, let's say, power supply. You don't need any control channel and so on and so forth. But obviously, smart skin have a great, let's say, limitations, are not reconfigurable. So you design them once, and then as long as you deploy them, you cannot change the configuration. So if the user are moving, or if you want to consider a dynamic situation, they could not be a good solution. So this is the main, let's say, limitation for smart skin. In addition to the smart skin, we can think also about frequency selective metasurfaces that are actually smart skin but are frequency selective. They are also called metaprisms. What is the idea? The idea is the following. So if you make the metasurface frequency selective, then imagine, for instance, you have an OFDM signal impinging this surface. And FDM is composed of several subcarriers of different frequencies. So if the metasurface is frequency selective, then you have that each subcarrier is reflected to different angle. Then instead of configuring the metasurface, you just change, if you want to change the direction of the beam of the steering, okay, or the beam steering, you just to change the way you allocate the subcarriers to users. Okay, so suppose you have a scenario in which you have several users, so user 1 is a certain angle, user 2 another angle, and so on and so forth, so that if you want to reach user 1, you just assign the subcarrier to that user corresponding to that particular reflection.
Yeah.
So this is the.
So do you think that it has applications in high mobility sort of scenarios?
Yeah, it could be useful for such kind of applications. Obviously, the main advantage is that this technology is transparent to the wireless standard, because in principle, as long as you use FDM, you don't need any, let's say, communication between the surface and the base station. You don't need any protocol, you don't need any power supply, so it's completely static. So perhaps you don't need standardization, I don't know. So this is main advantages. And at the same time, you don't, the surface allows you to manage dynamic situation, as you mentioned. Dynamic situation, obviously there is no freelance. Freelance, the main disadvantage that
the main principle of wireless communications.
No freelance at all.
Yes.
So that the main limitation of this technology that if you have one user in certain direction, so you can assign 1, 2, 3 subcarriers to that users, no more, because other subcarriers, let's say, point to different directions, so you cannot reach that user. So I think that this kind of technology, the metaprism, is appealing for those scenarios in which you have, for instance, a lot of sensors, for instance, a lot of low complexity devices, each of them with a low data rate requirements, not for a scenario which you have just 1, 2, 3 users with high data rate requirements. So this is in my opinion, perhaps the best scenario in which we can apply the metaprism. So the name obviously, metaprism recalls the ways.
And you think they are easily deployable on our current infrastructure? So let's say when we are moving towards 5G Advanced and 6G, as you mentioned, that we don't require to standardize this technology. So you think that this is easily deployable on our current infrastructure? We don't really need to think much about this, there are not more complexities associated with the technology.
I would say that it's quite easy to be deployed. Obviously, the main question is how to design this metaprism, because what you need to do is to to know in advance what is the angle range you want to cover within the bandwidth of the signal, and how to make the surface sufficiently frequency selective in that band.
Yeah, so just continuing on that, so you see that in 6G framework, or IMT 2030 that we call it, so basically we see one key usage scenario of integrated sensing and communication. So basically you kind of integrate sensing and then communication systems together under one network, you kind of coexist them, or basically in the same hardware as well, right? So the idea is that, do you think Metaprism or smart skin technologies, they can be adaptable to this kind of integrated scenario of sensing communications, and perhaps with localization as well? So what are your thoughts on that?
Yes, sure. There are some preliminary works that show that the Metaprism can be used successfully both for communication but also for localization, in particular for localization behind obstacles in non-line of sight conditions. So imagine you have some users or devices behind an obstacle, so instead of heading a base station or an access point in addition to the main one, you can put this very simple surface, metaprism, and then you can exploit the metaprism in order to perform angle of arrival estimation, for instance, because by changing the allocation of the subcarriers, you change the angle view of the metaprism, so that there is a way to localize something which is behind the obstacle. So that might help in the integrating sensing communication, in particular providing sensing localization, for instance, in non-line of sight conditions at a very low cost, so without having complex infrastructure as typically required for positioning. You know that positioning typically you need 2-3 anchor nodes before you are able to localize. So this, from the infrastructure point of view, could be very, let's say, costly. Okay, instead here you just, let's say, deploy very low cost sheet metaprism sheet-like device, and then by playing with subcarriers, you are able to localize, let's say, beyond the corner, in all line of sight, so you can see beyond the corner.
Beyond as well, and you see that because we are also moving, let's say, from far field communications to sort of near field approaches. So you think that this also fits very well with their scenario of indoor communications or near field based communication, or do you think that it is adaptable to both the far field and near field scenarios, or one or the other? I mean, I want to ask, what's the real benefit with near field or far field?
I think that the benefit can be obtained in both cases, both in far field and near field. Obviously, in near field, the design is a little bit more challenging because the frequency selective phase profile to design is more complicated if you want to perform focusing instead of being steering like in far field. But I think you can get some advantages using this metaprism even in the near field. But in particular, since these are expected to be very extremely low cost devices, then you can make them very large, and then if they are very large, it is likely you work in the near field. So you can say create the near field propagation.
Really get high degrees of freedom with
at low cost.
Low cost.
At low cost. So in this sense, I suppose that this could be very advantage, technology.
Right. And do you have any, let's say, efforts going on in these technologies, or any projects that you're actually working on, or any hardware demonstrations that you're working on, any prototypes or something that you would like to mention, just to understand the kind of progress of this this topic?
So at the national level, so the Italian level, we have big projects, in the telecommunication field, and one of these big projects is related to smart radio environments. I'm the PI of this project, and within this project we are studying also Metaprism. study not only from the signal processing point of view, but also we have people working in the field of antenna design, metasurface design, and so on. They are also thinking how to implement metaprisms, especially at low cost. So there are some ideas. So very interesting ideas. So we suppose that within, let's say, the next year, we should be able to build up a prototype and provide a demonstration of this idea of the metaprism in both for communication and localization.
Right.
Yeah. And then I would like also to mention that this year is the anniversary of the birth of Guglielmo Marconi. You know that Guglielmo Marconi lived in a villa close to Bologna, so close to our university, and he did the first wireless experiment in non-line of sight condition, about 2 kilometers in 1895. And then within this experiment, you know that the Marconi launched the first, wireless signal, and on the other side of here there was a man whose name was Celestini, and he was told to shoot with the gun in case he received the signal, and that happened.
Yeah.
Okay? So since this year and also next year we have the celebration of Guglielmo Marconi, then what we plan to do with other colleagues also is to make again this kind of experiment. So in the same villa, the same hill, and so on.
Interesting.
But using the metasurfaces. So working at high frequencies, for instance, a millimeter wave. So to establish a link in non-line of sight condition at the millimeter wave with the aid of a RIS or smart surfaces is just a demo, okay?
Yes.
Just to celebrate Guglielmo Marconi, so that in the same location after more than 100 years, we replicate a sort of, Celestini experiment. The name of the experiment is Celestini, which is the name of the guy who shot, the gun. So this is our idea. Obviously, everybody is invited to the celebrations at the Guglielmo Marconi Villa, and in particular Guglielmo Marconi Museum during this year and also next year. And so this is, I think, very interesting occasion.
Yes, indeed. So anyone watching from the audience might be catching this podcast earlier and might make it.
So basically, we link the past to the future.
To the future,
the past to 6G, which is the future. So this is
especially with recent Metaprism as
exactly.
It's quite interesting.
New technologies.
So maybe on the last, I think we perhaps can touch the future prospects of generally of smart radio environment, because you have been quite involved over a number of years. So you have been also working, I remember, on sort of NTN sort of technology as well. So we see that smart radio environment can be actually deployed on several sort of use cases and applications. So can you think of any sort of future prospects of let's say in general smart radio environment, including Metaprism, our new term called stacked intelligent metasurfaces, whether reconfigurable or non-reconfigurable, whether passive or active, hybrid, holographic. So what kind of future prospects that you can actually think of or share, some thoughts on that?
That's my opinion, possible perspective for risks in general, so for smart radio environments is the possibility to perform signal processing operation directly at electromagnetic level.
Yes.
In order to reduce the latency, reduce the complexity, reduce the power consumption. For an example of this is a very recent technology called the stacked RIS,
right,
in which you put several, layers of RIS, and you can optimize the elements of the RIS in order to perform some mathematical operation. For instance, the singular value decomposition or angle variable estimation. So this is very promising. In perspective, you could also make, for instance, deep learning stuffs directly at the electromagnetic level. So that would help in saving energy, which is an important aspect.
Yes,
because
exactly.
artificial intelligence stuffs are expected to consume a lot of energy. So
Yes.
if you can save energy through new technology.
There's a new term that is coming as well, is sort of electromagnetic signal and information theory, where we actually sort of combine several approaches together. So as I say that, generally you can deal with sort of electromagnetic equations or Maxwell equations. You can throw in some probabilistic models from your information theory, try to approach them with optimization, compressed sensing, signal processing sort of approaches. So we can actually combine various sort of fields together, especially when we require like high data rates and we want to save the costs. And we want to keep adaptability, so to say, dynamic sort of approaches we require for our transmission, at the same time reception as well. Thank you so much for taking time to speak over this topic.
Thank you for your invitation, and also invite all the attendees to even Marconi events, or more in general to come in Bologna and enjoy Bologna. Thank you for inviting me again.
Thank you, and we catch up with the audience in the next episode.